Welcome everyone. Welcome to yet another video on real analysis. We've been doing real sequences, right? And we have we have seen certain properties of sequences and certain theorems and certain problems, right, to prove the convergence. Let's move ahead and let's do more properties of the sequence, right? So let's write down this theorem. Okay, so theorem is about the limit, right? What's the limit can be. So um, every convergent sequence, right? Every convergent sequence xn, right, converges to a unique limit. If the sequence is convergent, then you cannot have more than one limit to that sequence, right? It has to be converging to a unique limit. That means if a sequence has two limits, both must be equal. Okay, that's the meaning. Okay, let's prove this. Okay, so let xn be convergent sequence in R, right, such that xn converges to x and xn also converges to y, right? What I need to show is, my claim is, these 2 points cannot be different, right? It has to converge to a unique limit. So if it converges to this same sequence converges to 2, it's a function, right? Remember, it's a function, so it's kind of it cannot go to 2 points, as n goes to infinity, right? That's kind of the idea, so what happens is, this must be equal, right? So my claim is x, you gotta be equal to y. Okay, so let's do this. So for this matter, let's start with any positive real number. So let epsilon greater than 0 be arbitrary, right? Epsilon greater than 0 be given to us. Okay, what we're gonna do is we're gonna show that x is equal to y. Okay, so how do I show that x is equal to y? Remember, if x is equal to y, or what I have to show is distance between x and y is going to 0, right? Or in other words, I have to show that this is going to 0, or in other words, I have to show that x minus y is less than epsilon for every epsilon positive. This is positive, this is positive, so if this distance is less than every positive number, then this must be 0. This is non-negative, remember, modulus is non-negative, right? And this is a positive number, so every positive number, this number, a non-negative number which is less than every positive number is 0 itself, right? So that's the idea, proving something less than epsilon. This is a very concrete definition in real analysis, right? It's showing that some distance is less than epsilon for every epsilon positive, right, means that this number is 0, right? So let epsilon greater than 0 be given to us. All right, so let's proceed. Let's use this fact. So since xn is given to converge, right, xn converges to x, this implies for this epsilon which is given to us, right, this implies for epsilon greater than 0 which is given for given epsilon greater than 0. Let me write it properly so that you would understand, I'm not making a mess. For given epsilon greater than 0, there exists some n naught, or let me use some n1. You realize why I'm not using n naught, n1 in n, right, such that whenever n crosses n1, distance between xn, or the modulus or absolute value of xn minus x, is less than, well, if it is less than epsilon, it is less than every number bigger than epsilon, right? And epsilon is just arbitrary number. So what I can do is this, for given epsilon by 2, if epsilon greater than 0 is given to us, I can select any number like epsilon by 2. There is this n1 in n such that I just want this to be less than epsilon. That's the only thing. Okay, you can also take epsilon, there's no problem, but eventually I want it to be you'll realize why I'm taking epsilon by 2. So this number is my choice. I can also take epsilon because epsilon is any number, right? So, and it's arbitrarily small, remember that, so anyway, similarly, since yn converges to y, sorry, since xn, since xn converges to y, this implies for the same epsilon by 2, there exists, I can take the same epsilon, there exists a different n, right? Say n2 in n, such that for all n bigger than or equal to n2, what happens is distance between xn and y also becomes less than epsilon by 2, right? So what happens is, this is true for, if I'll draw it on a number line, this inequality is true for all n which is bigger than n1. So all it's true for, this inequality is true for all the n's here, all the xn's lying here, and this inequality is true for all xn's lying somewhere, say suppose n2 is here, right? So both these inequalities would be true, right, whenever I mean, both this inequality will be true for n2, right? But n2 is what? n2 is maximum of n1 and n2. Similarly, if n1 is a maximum of n1 and n2, so n2 will be here, n1 would be here. So this is true for all n1, this is true for all n2. So both these inequalities will be true for the maximum, right? So what can I do is choose, right? Let's write that. Choose n0 to be maximum of n1 and n2, right? Therefore what do we get is absolute of xn minus x is less than epsilon by 2 for all n bigger than or equal to n0, right? Because n0 is bigger than or equal to n1, isn't it? Right? It's a maximum of both, right? And what happens to y, xn minus y? This is also less than epsilon by 2 for all n bigger than or equal to n0, because n0 is bigger than or equal to n2 also, right? So therefore what do we get? Therefore now it's just rearranging and some manipulation. Therefore what happens is, I want this to be less than epsilon, remember this, right? So this is nothing but this is equal to x minus xn plus, I'm adding and subtracting with xn minus y, right? Then I club these, use triangle inequality. This is less than or equal to absolute of x minus xn plus absolute of xn minus y. But this is same as, I can a minus b, the distance between a minus b is same as distance between b minus a, because I'm using absolute there, right? So this would be same as xn minus x, right, plus xn minus y, and this is given to be less than, epsilon by 2, this is given to be strictly less than epsilon by 2, which is equal to epsilon, right? And this is true for all n bigger than or equal to n0. This would imply that what, x minus y is less than epsilon, right, for all n greater than or equal to n0, right? Therefore, since epsilon greater than 0 is an arbitrary number, I'm just writing this for the starting part because this is the first proof you are doing. Since epsilon greater than 0 is an arbitrary positive real number, this would imply that, what would this imply? Distance between, you don't have to write this, the proof is over from here. This implies distance of x and y is less than every positive real number. This is not a part of the proof, this is for your understanding what this means, right? The idea is from this implies x equal to y, the idea is done right from here itself, right? So this is for your understanding, okay? So every positive real number, right? But distance of any two, distance between any two numbers, let me write that, distance between any two numbers is a non-negative number, isn't it? Distance between any two numbers is non-negative, right? isn't it? So this implies non the only non-negative, right? Only non-negative number less than every positive number, less than every positive real number is 0, right? Isn't it? This implies distance between x and y must be equal to 0. The distance between x and y, right? I'm just using distance here. We know what's distance, right? We said that distance is modulus, right? That's x minus y equal to 0. If modulus of a number is 0, the number has to be 0. This implies x minus y is to be 0. This would imply that x equal to y. That's the idea, right? This is the first time I'm doing the proof of this sort, so I've just given you the ideas, continuous ideas, but that would not be done every time. Be careful about this. All right. Okay. Let's look at more theorems of this sort. Okay. Let's look at more theorems of this sort. Okay. So let's look at more theorems. So let x and y and be convergent uh, sequences, right? Such that this is called algebra of sequences. Okay, the name of this thing is algebra of sequences. Or let's do that. Under algebra of sequences, right? We are doing this theorem under kind of algebra of sequences, right? So let's do that. You know, this is typing. Wait a sec. Let's do that under algebra of sequences. Algebra of sequences, right? Theorem. Let xn and yn be any two convergent sequences such that xn converges to x and yn converges to y, right? Then if xn converges to x and yn converges to y, then first one, you take xn plus yn, the sum of the sequences would converge to the sum of the limits. So if xn converges to x, yn converges to y, then if you add x and yn, they would converge. This sequence, one sequence, right? The sum of the sequence would converge to x plus y. Similarly, if I do difference, that is x minus yn, then it will be converging to x minus y. That's the first theorem. Okay, the first thing we would have to prove. Then if you multiply a scalar if you multiply a scalar number to a sequence xn, and suppose xn converges to x, then a scalar multiple of that would converge it to the scalar multiple of the limit. Third one, the product of two sequences where the product is taken term by sum, like if I look at x1 x2 so on up till xn and so on, and y1 y2 so on up till yn and so on, then xn y1 means x1 y1, xn yn means x1 y1 comma x2 y2. You just corresponding product you have to multiply, corresponding terms you have to multiply, and so on, right? x1 y1 x2 y2 and so on. This would converge to the product of the limits, right? And fourth one, if you look at the quotient of the limit, would converge to quotient of the limits, right? Quotient of the sequences would converge to quotient of the limit, provided yn is not equal to 0 for every n in n and y is non-zero, right? That's the only requirement we have to worry. Okay, let's look at the proof.
Because you would be using this uh, or one December walking. Yeah. So let's do it. implies given so this epsilon there exists n1 in n xn minus epsilon on n as yn is like given with this epsilon, right? I can find another n2 in n for this sequence, right? Such that what happens is y becomes less than epsilon by 2 for all n bigger than or equal to, right? Same logic, I have both this inequality to be true, right? I could, and then I have two n's, right? N into. If I want both the inequalities to be true, I got to choose the maximum out of n1 and n2, right? So choose n naught to be maximum of n1 and so what will happen? Therefore, what we get is for all n naught, right, which is bigger than xn minus the less than epsilon, and this is uh, what is happening? All and this is also true and y y is also equal. Therefore, what we are doing is we are therefore what happens to 10 plus 1 here the idea starts. I want to show that this minus this so what is xn plus y what I estimate this minus x minus y, right? This is just v plus yn minus y, right? And if I use a triangle inequality, this is xn minus x plus yn minus y, isn't it? And we have just xn minus x minus y is less than epsilon by 2. So this is less than epsilon by 2 plus epsilon by 2, which is equal to epsilon for all n bigger than or equal to. So what do we get? It implies that xn plus yn once and its limit is less than epsilon for all n bigger than or equal to n naught. And this is true for any epsilon. So this distance, whatever the distance is, it's less than epsilon for every n bigger than or equal to n naught. Right? So what does it mean? It means like that. 10 plus yn converges to x plus, right? What I said was then, what happens is putting x and right? So what would be the difference? Till here everything would be same. So down with the help of the above two. Till here it's all okay. The difference is made here, right? So if I replace then I can use yeah. And if I multiply negative sign inside, this will be plus, right? So this would come here and this would be yn, right? And this will be negative and positive. So we will take the this is as it is negative y, positive y, and this will be that plus yn minus y, right? That would be still less than epsilon by 2 plus epsilon by 2, which is equal to epsilon for all n bigger than or equal to n naught. What do we get? This minus this is less than epsilon for all bigger than n for all n bigger than or equal to n naught. What does it mean? That xn is xn minus y would be convergent to x minus y. The same proof But the only idea is to find it. And then you got it. Right? Otherwise it's just internet. Uh, well, okay. Let's what if he is zero? I mean, let's give two zero, then zero times zero times some number or non-zero number. Okay. Well, therefore, for epsilon by this is non-zero. It will be on. So for right, let's say for this epsilon now epsilon by what modulus t. This is always positive. Now this happens for any epsilon. For this epsilon that exists, right? So epsilon converge this way. And this happens for any epsilon. Therefore, for epsilon by absolute of t positive, there exists an n not in n, right? Such that what xn minus n what happens is xn minus x, right, is strictly less than epsilon by modulus of c for all n bigger than or equal to n, right? Therefore, what happens to this would be equal to I can take c common and what I'll get is xn minus the bracket. But c comes out of the modulus. We know the property of the modulus is modulus of a into b is nothing but modulus of a into modulus of b, right? So this is nothing but modulus of a into modulus of xn minus x. But we know that this is epsilon by absolute of c. So this will be absolute of c multiplied by epsilon by absolute of c. This will get cancelled, and this is epsilon for all n bigger than or equal to n, right? What do we get? This would imply that absolute of a is less than epsilon for all n bigger than or equal to n, right? This would imply that cx converges to as simple as that, right? So this proves something we kind of worried about. Just doing a nice kind of a flow to each of the proofs, right? Let's look at the third one, right? Third one to work out, but let's see how and what we need to work. So let's start with so we started with the convergence part and then let's talk about this. Let's go down. Okay, so together with the the cases, but when you prove it for some one of the of manipulation we got to do. Okay, so what is it? Because I only have right. So this is y, and I want to somehow get into extend manifest multiply x into xn into y, right? Plus xn into y minus, okay? This would be equal to, what I can do is this, what I can do yn minus y, right? Plus, what I can do is I can take y common from here, and what I get is xn minus, right? Multiply. Now use the triangle inequality. This is less than absolute of yn, right? Plus absolute of y into xn minus. So this is equal to, from here this is equal to x, because this is like absolute of b. This is like absolute of xn into yn minus plus absolute of y into absolute of xn minus. Right? Now we got three things. We got estimate gain, the gain formula of x. So x is somehow I make this for some of us. Okay, let's do that. That's the very first step we notice that is extend is convergent, right? This would imply that extend is, right? Is extend is common. This implies that there exists something like that. So such that we can bigger than something like this is true. Right? Also, we extend, alright, alright, and also since yn converges to y, this implies given. Now I look at that, this would be less than m, and I got to cancel this. Right? I got to have for given epsilon by 2 m positive. This is in particular, there would exist a n1 such that for all n bigger than or equal to 1, what happens is yn minus should be less than epsilon by 2 times m. I hope you understand that we have to do it, right? Now, similarly, we do it here, right? This is not proved yet. Hope it's clear. This is what we need to do. I hope that part is clear, but it's not proved. We are still trying to do it. Okay. So, uh, similarly, as y similarly, it's like g1 epsilon by 2 times. Now be careful. There's y here and I want to get cancelled by something here. But I don't know the nature of y. I don't know the nature of y, whether y is 0 or not. To be on a safe side, what we do is we take this to be absolute of y plus 1. So whatever it is, I mean, always 1, right? So this is for this epsilon, there exists some n2 in n. What will happen is absolute of xn minus. For this epsilon, I get n2 in n. This is less than epsilon by 2 times y plus by for all n bigger than or equal to n2, right? Now we have three n's, right? One is n1, and I want one n for which all these three inequalities precisely this inequality, this inequality to be true, right? So choose and not maximum of 1, n1 and n2, right? Such that for all n bigger than or equal to n naught, what will happen is absolute of xn will be less than n, right? Isn't it? Then xn would be less than epsilon by 2 times modulus of y plus 1, right? And absolute is is not the maximum of 1, n1, and n2, such that what will happen is for all n bigger than or equal to n0, right? Absolute of xn minus would be less than 2 times y plus 1, and absolute of y would be less than 2 times m, right? Therefore, now our estimate, which we had already estimated from here, right? What we get, therefore, absolute of x1, which was nothing but which was less than equal to, which was into, right? That is, uh, yeah. Plus this is absolute of y into absolute of xn minus x, right? And now we know that this is less than, this is less than m, this is less than epsilon by 2 times m plus absolute of y into this is less than, this is less than absolute of epsilon by 2 times modulus of y. Okay. So what will happen is this m will get cancelled. And what we know is absolute of y plus 1 is always bigger than absolute of y. Therefore, if I divide absolute of y by absolute of y plus 1, this becomes strictly less than 1, isn't it? Right? Isn't it? And if I multiply a positive quantity on both sides, it will be strictly less than epsilon. Do you see this? This less than 1, and if you epsilon is positive quantity, so if you multiply both sides, body is still reversing. I mean, it's still remaining in the same direction. This will be less than this because this guy is strictly less than 1. So this will be less than epsilon by 2 plus this guy is this entire thing, whatever we have, from here, this is strictly less than epsilon, right? And if you multiply by 2 here, this will be strictly less than epsilon by 2. So this entire guy, whatever we have, is strictly less than epsilon by 2. So this is less than epsilon by 2 plus epsilon by 2, which is equal to epsilon for all n bigger than or equal to n. Uh, for all epsilon and every epsilon positive. So what does it mean? This means that y converges. If, we got x minus 4, right? So first thing first, what do we get? Y epsilon minus yn and over yn y. This can be just and y. Then I can separate the modulus x and y minus x y n upon absolute of y and y, which can be written as absolute of y into absolute of y. Then again you got to do some kind of modification, and then x and y, add and subtract x and y, right? So this is negative here, x and y positive, x and y, right, minus x y. You can see that that's the manipulation or the modification we got to do, right? And then you take common and then multiply, and as I can take xn common, right? And this would be y minus yn, right? And here I can take yn common, and what I get is xn minus x, right? Over y into absolute of y. Now I can use a triangle inequality, which is less than or equal to absolute of a plus absolute of b. Then I can take xn common, come out, and then this will be yn minus y. Previous thing should be y coming out, and this is n minus y. We know that both of them. So if I separate this give a complement to both the things, then what happens over y right into y, and things are not getting cancelled. And here y will get cancelled, and what will be left is xn minus x over till here y generally. Well, I suppose uh, error or something. I don't know because generally, what would I take xn if I take out? What will be y into xn, and then if I take y now, yeah, that's and that is a little bit of more modification would be done. Um, less than epsilon. So our claim is to make this less than epsilon with the denominator first. Okay. So, y. Therefore, for epsilon equal to 1, directly right, such yn minus y would be less than 1, right, for all n bigger than or equal to n1. Make for all n bigger than or equal to n. This would imply that absolute of y, right, which is nothing but absolute of yn minus y plus y, right, which is by triangle than equal to less than or equal to um, absolute of yn minus y plus absolute of 1. Therefore, what do I get is yn. Uh, this is 1 would be um, no, consider it, right? So this is y. Therefore, absolute of y would be equal to absolute of y minus y plus yn, right? This will be less than equal to absolute of y minus y plus absolute of y. This therefore the absolute of y is less than or equal to um, 1 plus absolute of y. This would imply that absolute of y, right, absolute of y would be bigger than or equal to, this is bigger than or equal to, what do we have? Uh, second I, um, yeah. Well, instead of 1, what I can do is this example, 1 because y is 0, right? If I take that makes more sense. This epsilon, right, bigger than take this by. So this implies yn is bigger than absolute of y minus y by. This would imply that absolute of yn would be bigger than 2 times y minus y would be y by. Therefore, if a is greater than or equal to b, then 1 by 8, which is 1 by yn, right, would be less than or equal to 2 over absolute of y. That's the first thing. No. All right. All right. Now let's use the fact that xn is bounded. Okay. Since xn is convergent, right? This implies n is bounded. Implies that the sum and for all n equal to 1. isn't it? Now I have made a arrangement for this. I made an arrangement for this. This is anyway would go along this line. Use the fact that y since uh since therefore given now we will because this is remember this will be 2 times y square if I put be careful what I for given silent by 4 times modulus of y square into m um, um, 1 of y square um, m, right? Epsilon bigger than 0, there exists an n2 in n, right? Such that absolute of yn minus y is strictly less than absolute y square over 4 times n for all integers all right. Implies 1 uh, all top therefore choose and not to be maximum of 1 and 1 and 2 for all n bigger than uh, 1 1 1 1 uh, by 1 n then we have what we have upon y we have 1 n minus y plus y into minus this is for all n less than m, right? This is less than 2 by absolute of y. There's one more absolute of y squared it becomes, and this is epsilon by 4 into absolute y squared m, right? Plus this is 1 over modulus of y into epsilon y by. So what will happen is this will get cancelled with this guy will get cancelled with this guy will get cancelled with this 2 and 2 will get cancelled. This would be equal to epsilon by 2 plus epsilon by 3 is equal to epsilon. I have this. Therefore, y is equal to 1 less than epsilon.